Hello and welcome to EELE 101, Introduction to C Programming. This week we'll be looking at functions in C, and the question we'll ask is how can we package our code so that we can easily reuse it at a later time. Okay, so let's look at a function in C. So here we will have a particular function which we are wanting to compute a value. So we are going to look at the second order polynomial where we have y equals ax squared plus bx plus c. And let's create a function to implement that. Okay, so we will call this f poly2 for second order polynomial. And we are going to pass it a number of parameters. So let's actually first look at this diagram down here, which I'm circling. And the idea here is we want to pass x to it because we need an x squared and just an x by itself. We are going to pass an a value for ax squared. We want to send in a b value to multiply b times x. And we want to send in a c value where we'll just add that scalar. And then we add up these terms, and we want to get the result back. Okay. So the first thing we have to do when we define a function is actually tell it what are the data types of these inputs. Okay. So in this example, these will all be doubles. So here we have to say that x will be a double. We'll put a comma. Okay, A will be a double. We separate it by a comma again. B is a double. We need to put a comma. And C is a double. Okay. All right. So this inside the parentheses defines what are the parameters coming in and the input types of those. Okay. Now let's actually go inside the function here. So the first thing we need to create is a local variable that will store our result. Okay, and this we will make a double. And then we essentially do the entire computation in this line where we multiply those input values. So here we have a times x for x squared plus b times x plus c. We are going to store that into y, and then we have to tell the function what we want returned. In this case, we want the variable y returned. Okay, so this is the only variable that we created. We could have functions that have many variables, and we have to tell it which one to return. Okay, and then ultimately, this defines the type of the function. So here we're saying this function will be returning a double type. Okay, and so this is what we have to do to create pretty much any function, is define the type of the function, define the inputs, and then do the computations that we need, and then return something back. Okay, so here would be an example of how we'd actually call it. So here we would say y equals f poly2. We are going to put in 5 for x, we're going to put in 2 for a, we're going to put in 4 for b, and 3.5 for c. Okay, so remember internally we are computing y equals ax squared plus bx plus c. So internally we will be computing 2 times 5 squared plus 4 times 5 plus 3.5, which results in 73.5. And that will come back out of the function and be assigned to y the way we've written it here. Alright, so let's go back to our original function that we had plotted before. Okay, and we are going to modify our program. So what we want to do is, just like we had seen before, is we want to create a function that's going to replace this line. Okay, and let's call this function P3. All right, so how do we do that? Okay, so just like what we had seen before is what we have here. Okay, for this particular example, the only thing we're going to pass in is just x. We're actually just going to hard code the other values, right? So we just have a single input. We have to define that it's actually a double value. Okay, so this is what's coming in. All right. Internally, we need a place to store the result, and this will also be a double value. And then here's the computation, where it's x cubed. Notice we're not using the power function. We'll just multiply it x 3 times, minus 6x squared, plus 4x, plus 12. And then we have to tell it, again, here to what we want returned. I mean, we could return x, okay, but we want the computation. Excuse me. And what is being returned is a double precision floating point, or a double. Okay. And how we would actually then use this function is this example here, where we're just saying use the function P3, and we'll just send a value x in there and get the result back. All right, so how do we actually use this in our program? Okay, first we have to create the function. Okay, now notice where we're putting this. We are putting this before the main function. Okay, we could put it after, but we can't put it inside the main function. Okay, so we're defining it outside the main function, and we're just putting it, right after the define statement and before main. Okay, so this is what we had seen earlier. So we're actually just putting this entire function here. Okay, and now notice in our code we've replaced all that computation, and here we are just calling the function. We're passing the value x to it, which gets sent in here. The computation happens, y comes back, and then we're putting that computed value into our y array, which we're indexing by I. Okay, so that's how you create a function and use it in your code. All right, previously we had searched for the min and max over a specific interval in our x array. Okay, so let's create a function that will do this for us. So then we can just pass in what we want and have it find a piece of information that we can use to locate the min and max. Okay, so what we want to do here is we're going to rewrite this code. So the function is actually going to return the index. Okay, notice it's not going to give us the actual maximum value. It will return the index, meaning we can use this index to locate the maximum value in the array. Okay, all right, and so here we're saying max location, so that the idea is the index location of where the max value occurs. Okay, we're going to pass in our an array and return the index. Okay, so let's look at how we're going to do this. Okay. All right, so notice we are going to pass in both our arrays. Okay, so if you look at previously, notice that the arrays were doubles. Okay, all right, so this means that the data type have to be doubles, and notice these square brackets. Okay, this means that we're passing in an array, and this is telling the compiler to say, okay, we need to know the location in memory where this array starts. Okay, so we're going to pass in both x and y, the arrays, and we also have to tell it how many points are in each array, and in this case they're the same number of points, so we only have to pass in n that we can use for both. Alright, okay, so here we essentially have our variables that we've used last time, where we can keep track of the min and max. Okay. Notice here we're only concentrating on the max value. Okay. So we're going to go through all the values again. We pass in the X array because again we want to check over a specific interval. Okay, so we're only going to worry about the interval in X from -1 to 5. And then here we actually keep track of where the max occurred. So we say if y max, which started a very large negative number, so if this is less than our first value in the array, which is pretty much going to happen every time, then we assign that as the new max value. And here, specifically, we want to keep track of the index. So here, notice we're saving I, which is the index value that we are using in our Y array. Okay. So this goes through the entire points. We only check it if it's in the interval that we're interested in, and then when we find the maximum value, we keep track of where that occurred in terms of the index. Okay, so this is I max is the index of the maximum value. All right, so when we're done, we are going to return I max. Now notice I max is an integer. Okay, so we've defined it to be an integer here. Okay, so since we're returning that, our function needs to be of type integer because we are returning an integer type. Okay, all right. So the example usage of this is we just pass in our X array, we pass in our Y array, and we pass in the number of points that are in the both arrays. And what gets returned is an index of where the maximum value is located. All right, so we can also do this, we can also create a min function here, which would be done in a similar manner. Okay, and this is actually how we would call the function and use it in the code. So in this case, we would pass it the X array, Y array, number of points. Okay, we use the function max location. It returns the index of where the max occurred. Okay, so now we can use that in our code to say, okay, YA of Imax is the maximum value. So we can actually just assign this here. Okay, and we also want to know the X value of where that occurred, because we later will want to plot the point as X and Y coordinate points. Okay, and so we actually get the values by using the index. And we can do this in a similar manner for min location, where we would search through and return the index of where the minimum Y value occurred. So now we can just look that up in the array because that will tell us where in the array this minimum value occurred. And we actually get the value with this statement here. And of course we want the associated X value so that we can actually plot the minimum point. Okay. All right. Okay, so if you compare the code here, then it becomes much more readable in terms of what's happening, and it's more compact in terms of code what's going on in the main function. So posted on the D2L site is the example code for this entire example. Okay, so you should open it up and take a look at it, and also notice how you should comment your code as well. So this will be used as a basis for your next assignment. Okay, so which is what? All right, well, last time you computed the maximum power that can be transmitted across a load resistance. Okay, so we will use this same problem, except what we want to do is create a function that will compute this power across the load resistance. And so we will need two parameters that will be passed in. Okay, because we have our voltage source that's been given by the user. We have the internal resistance that is also given by the user, and now we are essentially going to vary the load resistance as this parameter C, um, times the source resistance. Okay, and we want to again compute the load across that. Okay, so you essentially will take your code that you did last time and repackage it. Okay, in the manner that you saw today in the lecture. Okay, so what you need to do is replace where you're computing the load with an actual function call. Okay, so you need to create this function and use it in your code. And since we're trying to find the maximum power transfer, okay, you will also need to create your max location function just like we did before. The only difference is we don't need the x location because we're not computing over in the particular interval. You can search over the entire array. So you only need to actually pass in this power array that you're creating, and of course you need to give it the number of points, and then return the index where this occurred, and then use this to find the actual location and plot as you did. So the only thing you have to do is rewrite your code so that you use this function call for computing the power, and then finding a new, so create a new function that will find the maximum location in terms of the index that you can then go back in. So index actually here will actually go back in here, and your array of this index location will be the maximum power. All right, so that's all you have to do for this week in terms of programming. So good luck programming.